Hello again, Mrs. Bennett here, continuing our video lessons on rational functions. So the next thing that we are going to find are the x-intercepts of a rational function. And an x-intercept is where the function crosses the x-axis. So because the x-axis is right here, this is a y value of 0. So anytime your function, let's say our function looked like this, we have an x-axis or an x-intercept right there. What we're going to concentrate on is finding the x value, but we already know that the y value is 0. And you can see in the directions here it says sub n y equals 0, solve for x and analyze. Now sometimes there isn't an x-intercept, so when we go to find it, it won't make sense, which tells you that there isn't one. Okay, so we are going to take our function, our original function up here. We've already canceled out the wholes and calculated where the hole is, and you can see that wouldn't be where the x-intercept is. So we don't have to worry about this part of the function that we canceled out. What we need to worry about is the simplified part. So I'm going to write that down here. Y equals x minus 1 over x minus 3. And again, we know the y value is 0. So we're going to take a 0 and plug it in right here. Let me put my parentheses around here. And then what we are going to do is solve for x. So the first thing we have to do is get rid of the division. So we're going to multiply both sides by x minus 3. Which will still make the left side 0 and just leave you with the numerator of x minus 1. So 0 equals x minus 1. Now what happens, or what happened, you guys saw this when you did part 3 in the gizmo, because really we were just looking at the numerator. When we put 0 in for y, the denominator always cancels out. So we're really just looking at the numerator of for our x-intercepts. So we're going to solve this by adding 1. So we get x equals 1. So what that tells me is that our function has an x-intercept at 1, 0. We already know this doesn't happen where the whole value is, so this value does exist. Okay, let's show it on the second example. And what we are going to look at is really just the numerator, because we know the denominator will cancel out. So we're going to take our numerator, which is x plus 4, set it equal to 0. And we get x equals negative 4. So we should have an x-intercept at negative 4, 0. And that is how you find x-intercepts. You can also find these on your calculator. If you type in your function into y equals and then use second trace key and then choose zeros, and then you can calculate on your function where the 0 is, which is really the x-intercept.